What I'd like to show you is the Creo NC interface we have developed to support a mill turn environment. The first thing I'm going to do is select my machining environment. An interface appears. Now this is fully configurable by you. In this case, I'm going to pick the Morisiki mill turn and hit the OK button. What's happening now is configuration files and the window layout will update for my mill turn. It also checked out a floating license for me. First thing I would like to do is start a manufacturing model utilizing a predefined start template. I'm going to select this icon in the upper left hand corner. This interface appears here again is fully configurable by you, allowing me to input the name of the Creo NC model. You'll probably put in like a part number, hit the OK button. Template's retrieved and renamed to the name that I just input. This interface allows us to set up the mill turn environment. First of all, we can input the part number. We're going to use predefined bar stock, yes or no. In this case, I can input the stock diameter. I'm going to put 6 inches. Is this tubing? Does it have an interior hole? Yes or no. If it is, I can input what it is. This section right here allows me to input information about the main spindle. First of all, what is the jaw length from the chuck face? How much stock would I like on the front face of the main spindle? In this case, I'm going to leave it at 50 thousandths. Is this job going to be a bar feed or a soft jaw? In this case, I'm going to input soft jaw. The next prompt, I can actually input the distance between the chuck face and the back of the part. I'm going to continue on the second operation. Am I going to machine this second operation in the sub spindle, or am I going to flip it around in the main spindle? Or is there no secondary operation? In this case, I'm going to go ahead and transfer it to the sub spindle for the secondary operation. I can input information about the jaw length, the chucking depth. This would be how much the sub will actually grab onto the part. I can input the clamping diameter and how much stock I would like on the front face for the secondary operation. So we can always input this information right up front, and we can always come back and change it at a later time. I'm going to hit the OK button, and my workpiece updates based on the 6-inch diameter stock that I input. Now you notice at the top of the screen there are a row of icons that we're going to use typically through a manufacturing mill turn process. We're going to typically use these from left to right. I'm going to start out by assembling the reference model. Hit this icon. This map key pause window is going to appear giving us instructions on what to do. It tells me to open the reference model and hit resume. Now it's going to give me instructions on how I can assemble this part into this manufacturing model. The map key pause window gives me instructions on how I can translate it up and get it somewhat in the orientation that I'm going to be assembling this. The next map key pause tells me to select the OD of the workpiece and the OD of the design model. Hit resume. Now I'm instructed to select the back surface of the design model. And optionally, we can actually clock or actually position this part in the chuck at different orientations. So I'm going to select a planar surface that I'm going to use to locate this. In this case, it picked it normal to the center datum plane. If I would like to actually put a value in there, I could take it and dynamically rotate it around and or key in the orientation that I like. Hit the resume button. The part is now assembled. The next thing I would like to do is set the part length for the workpiece. This will allow the rough stock to actually grow and shrink based on the size of the part. To do that, I'm going to select this icon. It's going to prompt me to select some vertex, just any of them, on the front face of the part, and hit resume. So now the workpiece size is based on the size of the part. If I zoom up, I can see I have 50,000 stock on the front face for the main spindle, 50,000 stock on the sub side. Now this particular part, what I like to do process-wise in the main spindle, I like to face the part, rough and turn the OD of the part, drill a hole down the center bore this out, drill some holes on the front face of the part to mill this cam surface on the face of the part. And I'd also like to utilize for example, like a G68.1 type of format for drilling these angled holes. So the next icon I'm going to select, it allows me to set up the operation. Select this button. Operation shows up in this ribbon in the upper left hand corner. If I have multiple machine tools, I could select it at this point. If I had different types of materials, I could select it at this point. Where this comes in handy is if you have smart tools with predefined speeds and feeds based on materials, you could pick this material here, and then you would select the tool itself. Those speeds and feeds would be used. Hit the OK button. Next button over, I'm going to go ahead and start to work on the main spindle. So I will select this icon. Pulls up a side view, unblanks the chuck, and you can see based on the input on how it's going to actually hold the part, the chuck's going to hold the part, and the distance from this rough stock to that chuck face. Now, as it turns out, a lot of people like to, the first thing they do basically is they like to face the part. So in this particular manufacturer model, I already have a predefined sequence that does face the part. I'll select play path, and I gave it a step depth of 50 thousandths, so if it required multiple passes, it would have done that automatically. So the facing is done. So optionally, if I'd like to, I can actually do what we call material removal. I can update the workpiece based on the facing sequence I just created. I can select this icon, select the sequence, hit resume, and the workpiece updates. Next thing I like to do is I like to rough and finish the OD, and I like to output in a format that supports a can cycle such as a G251 or G76, whatever your machine has. So the first thing I like to do is to find the area I'd like to machine. To do that, I'm going to create what we call the turn profile. I'm going to select the main coordinate system, the reference part. In this case, I'm going to go ahead and drag a start and an end position for the area that I'd like to machine. You notice that what Creo does for you is it looks at the part as it spins in the chuck and gives you an outline. So I'll accept that. Now I have a predefined machining process saved out in my library. I'd like to apply it to this particular part. To do that, I'm going to select this icon. This interface is also fully configurable. So on the main spindle, I would like to rough and finish the OD supporting a can cycle. So it pulls up the UDF, and I have an instruction. It tells me to select the OD turn profile, this main clearance point, and the workpiece model. And then I can hit resume. Look at my model tree, and what I have here, I'll select play path, is a sequence, predefined sequence, that is going to rough and finish this particular area. We will show you later that it does support a can cycle. And optionally here again, I can select material removal to update the workpiece to show that we remove that material, that turning sequence. Next thing I like to do is I like to drill a hole down the center bore, pre-drill it, and then go in there with a small boring bar and bore out the ID. I'm going to utilize a predefined UDF for this drilling. So I'm going to be prompted to select the axis, the drilling depth, and it created my drilling sequence. I'll select play path, slow the display down just a little bit. In this case, it output a pecking cycle, so it drilled out the center bore. Optionally, if I'd like to, I'm going to go ahead and create a material removal for this particular sequence. So it updates the workpiece showing that that material has been drilled out. Now the next thing I would like to do is bore out the ID. To define the area I'd like to bore, I'm going to create what we call a turn profile. Select the reference part, drag this down to the center, and I can set this right here to the end point. And if I want to, as far as the direction, I could change it at any time. So there's my ID. Actually, let's move this down here. That is going to be the area I'd like to bore out. I have a predefined cutting sequence stored in the library to do the ID work. And this here again will support the can cycle for that particular machine tool. So I'm prompted to select the ID turn profile, a clearance point and the workpiece model, hit resume. I look in my model tree, and here I can see the sequences that support that boring. The next sequence type I would like to create will be a spot drill the holes on this front face. So I'm just going to do this through the menus. So I'll pick mill. In this case I'm going to create a countersinking type of toolpath. I'm going to select the spot drill. The references, this will allow me to select the holes I would like to drill. I'll select one, it grabs all of the same diameter. I'm going to start drilling on this surface. In this particular type of sequence, I can input the final countersinking depth. These are 100 thousandths diameter holes, so I'll put 120. So the depth will be calculated on the tool geometry to accomplish a 0.12 countersink. Parameters, I'm going to go ahead and retrieve some predefined parameters. Speeds and feeds, depth of cut. Clearance, in this case I would like to have a clearance maybe right off that front face, and I'll drag it out to about 53. Hit play path, and it's going to go around and spot all the holes. The next sequence type I would like to create is a sequence that is going to cut this outside cam. So I'm going to go to mill, I'm going to select trajectory milling, pick a predefined tool. The parameters, I'm going to retrieve some predefined parameters. Under here I'm going to actually follow the curve, so I'm going to select the curve on the edge of the cam surface itself. I can hit play path, and the tool is going to follow that cam surface. Now one thing I do want to point out, in this particular machine we have a format called G12.1 which outputs a certain type of cutting motion on this mill turn machine for face milling. You may notice I don't have to tell Creo NC to support that. When the post-processor executes, it's going to know what type of sequence this is, and it will automatically put it in that proper G12.1 format. So I milled the cam surface. Next thing I would like to do is I like to drill these 3 holes on this canted, this angled surface. This will utilize, on some machines, a can cycle such as G68.1. So first thing I'd like to do is I want to put a coordinate system in the center of this center hole, normal to that surface. So to do that, I do have a predefined UDF that allows me to do that very easily. So I'm going to be prompted for a few things. The first thing will be the whole surface itself, the top planar surface, and a vertex. So there I have a hole at the center with Z pointing out. So I'm going to go to my mill sequence. In this case I'm going to do a standard drill. Ribbon interface displays. I'm going to pick a tool that I don't have on the list. So I'm going to the tool manager. And if I don't have it predefined in this tool list, I can go to my library and retrieve a predefined drill. So I'm going to pick a 100 thousandths drill. References, in this case I'm going to tell this sequence that this will be my sequence coordinate system, which establishes the orientation, also helps me pick the holes just in that orientation. So one of the references, as far as the holes, I'll select one of these holes. It picks all 3 because they're the same diameter. Parameters, I'm going to go ahead and retrieve spot drilling sequence, speeds and feeds, things like that. Now the clearance, I'm going to go ahead and have a clearance plane based off of that surface. Now as far as controlling the starting surface and the depth of the drill, I'm not going to use auto. You can. What I like to use, I like to implicitly say I want to start drilling on this surface, and I like to typically either key in a depth, or I can actually pick an existing surface off the model to control the depth. So I select play path, and it's going to go through and it's going to drill all 3 of those holes. Now I'm not going to completely machine this part. This is a high-level demonstration, but we will say at this point that the part is completely machined on the first operation. So I'd like to proceed to go to the sub-spindle. To do that, I'm going to select this icon up here. And based on the information that I input, it's going to grab on a 2.5 inch diameter, which I input, and how much of the part does it grab on. Now that's not a very sturdy clamping situation. So I'm going to go back to these manufacturing parameters, selecting this icon. This interface reappears. There's one thing I did not input that I do want to change, is how much of the sub-spindle jaws do you want to grab onto the part. I'll put 2.25 inches. And you can see the manufacturing model updates. That looks a little more secure. Now I do already have, I'll hit select play path, on a predefined sequence that will automatically face the part in the sub-spindle. What I like to do next is I'd like to create an OD turning sequence to machine this material off. So the first thing I'm going to do is create a turn profile to define the area to machine. So I like to actually just kind of drag, put my start down here, so this will be the area I'm defining to machine. Now I have a predefined sequence in my library I would like to apply to this. So I'm going to go ahead and run and finish the OD supporting a can cycle. I'm going to select the OD turn profile, the clearance point, the workpiece model, and hit resume. I look at my model tree and I have sequences that support cutting that OD in a can cycle format. Here again, optional, if I wish, I can go output a material removal to update the workpiece. So at this point we'll say the part is completely machined. We did a lot of machining in the main spindle, we did some in the sub spindle, so at this point I am ready to post-process and create the NC program. So I'm going to select this icon up here. Now in the beginning we select the mill turn environment for Morisikis. So this interface, we're going to see a list of post processors that are valid for this environment. So I'm going to go ahead and select this particular machine tool, select the set, and hit resume. So what's happening now is the post processor is executing. I'll hit resume. This is something we can utilize to review and transfer our NC program. So first thing I'm going to do is I'm going to select View Edit. And this is the NC program we just created. It created a nice tool list, information on all of these sequences. There's the first facing sequence. Here is the first sequence on the main spindle that did the OD turning. You can see it outputs a can cycle called G271. Drills a hole in the bore, simple G83. Roughs out the ID utilizing a G271. This is where I drilled all the holes on the face. So positions, and each hole it indexes to the proper C. This is where I machined around the cam surface, outputting a G112 cycle. The G112 cycle will position the tool in the upper X quadrant, and the milling motion will involve a lot of C rotations along with some, in this case, some X moves. So you can see this format was automatically selected based on the type of sequence. This is exactly what I want. Then I continued by drilling the holes on that canted surface right here, and it outputs the proper format for that machine tool. So I'm happy with this program. Looks good. So I'll come back to here. I can hit this transfer icon and it will send this NC program to a predefined DNC or directory location where a DNC system could pick it up, transfer it, or an operator can look to upload it to his machine and run.